Hello, in this video we're going to be talking about Chapter 12, Section 3, which includes gathering weather data. Our goal for this section is to understand that accurate measurements of atmospheric properties are a critical part of weather analysis and prediction. Your essential questions for this section include these three questions. Why is accurate weather data important? What are some of the instruments used to collect weather data from Earth's surface? And what are the strengths and weaknesses of weather radar and weather satellites? These are your vocab terms. You should be able to define these. Remember, your test is going to include information about these words. I probably won't ask you what these words mean, for example, but I'll ask you questions that include these terms, and so you have to understand what they mean in order to answer the questions properly. For example, I might ask you a true-false question. Say, true or false, a barometer is an instrument used commonly for the measuring of temperature. And hopefully you would know that that's false. What I was going at was the definition for a thermometer. And so I might do some mixing and matching on true, false, or multiple choice questions to try to throw you off. So be sure you know what these different instruments are and what they do. Okay, so that includes thermometer, barometer, anemometer, hygrometer, radiosonde, and Doppler effect. And know the Doppler effect. We'll talk about that in the slideshow. So data from Earth's surface. Two important factors in weather forecasting is the accuracy of the data and the amount of available data. And this is why we need a lot of instrumentation. And we need to spread the instrumentation out. Temperature and air pressure. So two devices that can be used for measuring, the first being a thermometer. A thermometer measures temperature using either the Fahrenheit or Celsius scale. And if you look at the word thermometer, this is a device that measures thermal energy, thermometer. Barometer is going to be measuring pressure, barometric pressure, which means that we're going to be measuring atmospheric pressure, and atmospheric pressure is caused by gravity and the fact that there's lots of air molecules above us. Gravity is holding us down to the ground, and because we're close to the ground, we're here with most of the air molecules, and those air molecules also are being attracted to the ground. And that column, that imaginary column of air that extends from your position all the way up into the end of the exosphere, that's going to be creating a pressure because those air molecules are all colliding and bouncing off of each other and off of the surface of your body, creating an air pressure. So a barometer measures that air pressure. Wind speed and relative humidity. So we also have a device, we have an instrument for measuring wind speed. That device is called an anemometer. We have a hygrometer, which is used to measure relative humidity. In the picture here, I have an image of a anemometer, and in the background you see a tornado. So there might be a correlation there between the two. I'm not sure if you necessarily need an anemometer to be able to know that a tornado is nearby, but there you go. Automated surface observing systems. We have these weather stations around, and they are used to gather data in a consistent manner 24 hours a day, every day. And they provide essential weather data for aviation, weather forecasting, weather-related research, etc. I've talked before about how it's important to have data. Data can be used for statistical analyses, for analytics, and so if you have data, you can compare current conditions to historical conditions and historical weather to be able to predict future weather based on your current weather conditions. So for example, if you had a combination of pressure and temperature and things like that, say a couple years ago, and when those conditions were just right, we ended up with a storm or something like that, you could infer that a storm is likely because the conditions are similar now as they were the last time there was a storm, for example. And that's how statistical relationships can be used to predict the weather. We also can gather data from the upper atmosphere. In this picture here, we have someone preparing a weather balloon. And on the end of the weather balloon is a detecting instrument that includes sensors for measuring air temperature, pressure, and humidity. And this is called a radiosonde. We can also gather data from space or from the ground by using Doppler radar. The Doppler effect is the change in pitch or frequency that occurs due to the relative motion of a wave, such as sound or light, as it comes toward or goes away from an observer. So you may have experienced this before. And what this would sound like is a sudden pitch in sound. So if you imagine an ambulance sound or a horn blaring of a car or a train, and that train is passing you, the pitch will shift the moment it passes you. Like it might go, and that's the Doppler effect. That change in pitch is because of what I just explained. And so you can analyze Doppler radar, and you can use your analyses of Doppler radar to determine the speed at which precipitation is moving. For example, you could track the position and the change in position of a hurricane, and you could help people to understand when a hurricane is going to make landfall. So you could help keep people safe, so people know when to evacuate, and that information is useful for saving people's lives. Weather satellites. Some weather satellites are using different types of imagery, including infrared imagery, and these observations can be made at night. And objects will typically radiate thermal imagery. Oh my gosh, thermal energy, and this can be used for thermal imaging. And depending on the temperature of the radiator, this is typically called black body radiation because each body radiates a temperature related to its a different frequency related to its temperature. And since our bodies, for example, human bodies, aren't that hot, but we still aren't cold or warm, we radiate energy at that certain temperature. There's a fingerprint temperature of, for example, a 98 degree body, and you can image that. And so if someone, for example, had a fever, you could see the difference in thermal energy of those two bodies. So it'd be very easy to detect, say, if someone had coronavirus, for example, because of their thermal energy that they're radiating. You can also look at hurricanes, and hurricanes will have a fingerprint thermal energy. You can compare them. If one hurricane has more thermal energy than the previous one, then you can kind of rank them and determine, or at least infer, how much energy they might have, how much energy they might inflict, damage they might inflict on an area. And you can analyze other things like wind speeds and the density of cloud cover and things like that to also try to infer how much energy, how much potential damage can be inflicted by a particular storm. But it's a lot more complicated than that. That's just a generalization. You can use water vapor imagery to predict how much moisture is in the atmosphere if there's no clouds. So for example, if there's no condensation nuclei, sometimes you can have a significant amount of water vapor in the atmosphere, and you won't be showing any of that because the moisture doesn't have anything to precipitate onto because there's no condensation nuclei. This is similar to when you have super cooled water in the freezer, and you look at it and you're like, wow, it should be frozen, and it's not frozen. Why isn't it frozen? And then you try grabbing it, and then you can watch it crystallize in your hand. Similarly, in the atmosphere, you can have an atmosphere that's super saturated with water without any condensation, and then something happens. There's a seed particle of dust, and then you start getting rapid condensation of the atmosphere. Maybe get a cloudburst, unexpected precipitation when previously the skies were clear. Sometimes that stuff happens. I've lived in places where that would happen, where it would be clear skies, and then out of nowhere you'd have rapid clouds forming and then rapid rainfall. All right, so that covers this chapter. Hopefully you understood what I talked about. If you don't, feel free to go through it again. I know I did it quickly, and so I'm hoping you're able to get what you needed to get. These are your essential questions. You should now be able to answer these questions. These are the vocabulary terms that I used in this section, so you should now be able to utilize these words in a sentence. You should be able to understand what these words mean. And so if I was to give you true-false questions or multiple choice questions utilizing these different words, you should be able to know the difference between those words. I hope you learned something. Hope you enjoyed the video. Thanks for watching. Don't forget to subscribe.